Okay, so this is the solution for Chapter 2, problem number 53. And so the problem says, setting a world record in a 100-meter race, Maggie and Judy crossed the finish line in a dead heat, both taking 10.2 seconds. Accelerating uniformly, Maggie took 2 seconds and Judy took 3 seconds to attain maximum speed, which they maintained for the rest of the race. A. What was the acceleration of each sprinter? B. What were their respective maximum speeds? C. Which sprinter was ahead at the 6-second mark, and by how much? Okay, so in my setup, I drew the two runners. Maggie, I just wrote M, and Judy, I used J. And so they're both running the same distance, the 100 meters, and they both finished at T equals 10.2. As you can see, Maggie was accelerating for only 2 seconds, and then she kept on running for the same speed, so her acceleration afterwards was 0. Whereas Judy, she accelerated for 3 seconds, and then she maintained the same speed afterwards, and so during that time her acceleration was 0. Alright, so that's my setup. Okay, so to find Maggie's acceleration, you have to draw the velocity versus time graph. And in the beginning, there's a slope because that represents the acceleration, since the derivative of velocity is acceleration. And then it sort of flattens out because you have constant acceleration after your 2 seconds. Okay, so the area under the curve we know is 100 meters because the velocity integrated would give you the distance traveled, which in this case is 100 meters. Alright, so I just called the height of that, I guess, triangle that you see on my graph the final velocity, because that is the final velocity after Maggie accelerated. Alright, so then you want to find that velocity so you can find the acceleration. Okay, so towards the bottom I wrote area is equal to 100 meters, which again, it's because it's the distance, is equal to 1/2 times the base and the height, which is 2 times the final velocity. And then you add that with the area of the rectangle, which you get 8.2 times the final velocity. Okay, so then you want to do some algebra, and you would get that the final velocity would be around 10.86 meters per second. Okay, so if you notice on the far right is where I found the acceleration. Since the acceleration is the slope at the beginning of the graph, you just need to find delta V over the delta T. So, we're going to, because the two runners start at 0, 0, we can use 0, 0 as one of the points, and also at 2 seconds and 10.86 meters per second. Okay, so plugging that in, you would get that that's the slope, and so then your acceleration would be 5.43 meters per second squared. Okay, so finding Judy's acceleration is done like about the same way. Okay, so I did the velocity versus time graph for Judy, and she accelerates until 3 seconds and then goes under constant acceleration. And so again, her total area under the graph is 100 meters because they both ran the same distance. So I found the area under the curve again using the V sub f as Judy's final velocity after she accelerated. Okay, so I wrote 100 meters is equal to 1/2 base being 3 seconds times the final velocity plus the area of the rectangle, which is 7.2 seconds, times the final velocity. And so again, you do a little bit of algebra, and then you find that the final velocity is about 11.49 meters per second. So you want to refer to the top right of the board again. And to find the acceleration, you need to find the slope, which is delta V over delta T. And again, we're going to use 0, 0, her starting point, as our second point. So we have the delta V over delta T there, and you should get that her acceleration is about 3.83 meters per second squared. So part B asks for their respective maximum speeds, which you already found in part A. So Maggie's top speed would be equal to her speed after she accelerated, which is what we called v sub f. And so we got 10.9 meters per second, and that's right. And so Judy's top speed is her speed after accelerating as well, which is what we also called v sub f, which is 11.5 meters per second, and we got that just by using the area under the curve. So part C asks you which sprinter was ahead at the 6-second mark and by how much. So then we need to find both their positions at 6 seconds. So to find Maggie's position at 6 seconds, you have to divide it into 2 parts. So I called the part 1 delta x sub 1 and part 2 delta x sub 2. So in delta x sub 1, it goes from t is equal to 0 to 2 seconds. So that is when she is accelerating. And so for delta x sub 2, the time was from 2 to 6 seconds when she is not accelerating. So we use the equation delta x sub 1 is equal to v sub I times t plus 1/2 at squared. And so because her initial velocity is 0, then that part just goes away. And so you plug in what we got for her acceleration, and you plug in 2 for her time, since that is when she continued to accelerate, or that is when she was accelerating, I guess. And then you get 10.9 meters. So then you have to look from the time that she wasn't accelerating, which is from 2 to 6 seconds. So then the second part of the equation goes to 0 because there's no acceleration. So you do what we got for her velocity. And her initial velocity from that segment is equal to our v sub f because that segment starts when she's going at that speed. So then you add those two together and you get 54.5 meters, and that is her position at 6 seconds. So Judy's position at t equals 6 seconds can be found in much the same way. So delta x sub 1 again is from, well, not again, but is a time that she's accelerating, which is from 0 to 3 seconds. And delta x sub 2 is from the t is equal to 3 to t is equal to 6 seconds when she is not accelerating. Okay, so in the delta x sub 1 again, you get you get rid of the first part of the equation because her initial velocity is 0 because she's starting from rest. And so then you plug in what we got for the letter B and A of this problem, and so then you get that. And then for delta x sub 2, you get rid of the second part of the equation because she is not accelerating, her acceleration is 0. So then you would plug in her velocity and time. And again, her initial velocity in this case is the same thing as the v sub f that we found in the previous, I guess, step, because she starts this segment of time at her max speed already. Okay, so then you get that, and you would add those two numbers together, the x sub 1, well, delta x sub 1 and delta x sub 2, and you get 51.74, and that should say meters. So I'm just going to write it. So afterwards, you can see that Maggie is faster, or not faster, but she was further along ahead than Judy was at 6 seconds. And so to find the difference, all you have to do is subtract Maggie's position with Judy's position, and you should get 2.7-ish meters when you do that. Although the book does say 2.62, I think it's just because it's rounding. So yeah, that is how you do this problem.